Picture this. You're standing at the edge of the deepest hole on the entire planet, and you can see less of what's down there than scientists can see on the surface of Mars. That's not me being dramatic. That's literally true. And by the time we're done here, you're going to understand exactly why the bottom of our own ocean is more alien to us than another planet floating millions of kilometers away in the cold dark of space. Okay, so if this kind of stuff makes your brain itch in the good way, do yourself a favor and hit subscribe. We post these every single week. You can even smash the little bell if you're feeling spicy. Cool? Cool. Now let's go drown ourselves in the dark. So here's where we're headed. There's a place in the Pacific Ocean called the Mariana Trench. You've probably heard the name thrown around. It gets mentioned in documentaries. It shows up in those little fun fact lists. People say it casually like they have any real grasp of it. They don't. You don't. I didn't either, honestly, until I actually sat down and tried to wrap my head around the numbers. And the numbers are insane. The Mariana Trench is this enormous gash in the floor of the Pacific, way out east of the Philippines, near a string of islands called the Marianas, which is where it gets the name. And at the very bottom of this trench, there's a specific spot, the deepest known point anywhere on the surface of the Earth, and it's got a name that sounds like it came out of a fantasy novel. It's called the Challenger Deep. And the Challenger Deep is so deep that your brain basically refuses to process it correctly. So let me try to fix that for you. You know Mount Everest, right? Tallest mountain on Earth, the thing people kill themselves trying to climb, the absolute ceiling of dry land. Now imagine you could grab Mount Everest, the whole mountain, base and all, and just drop it straight into the Challenger Deep like you're dropping an ice cube into a glass. You'd think, okay, that's a massive mountain. Surely the tip pokes out of the water. Surely you'd see the peak sticking up like an island. Yeah, no, not even close. If you dropped Everest into the Challenger Deep, the peak, the very top, the part climbers nearly die to reach, would still sink about 2 kilometers below the surface of the water. 2 whole kilometers of ocean would be sitting on top of the highest point on Earth. That's how much room is down there. And let me explain just how much volume we're talking about, because depth is one thing, but the sheer scale of the place is another. That one spot, the Challenger Deep alone, could swallow 5 Grand Canyons. 5 of them. The Grand Canyon, the thing that takes your breath away, the thing people fly across the country to stand and stare at, the thing that makes you feel tiny. You could fit 5 of those inside this one trench and still have room. And here's the thing that really gets me. The Grand Canyon is something you can see. You can drive up to the edge. You can take a photo. The Challenger Deep, this thing that dwarfs it 5 times over, almost nobody has ever laid eyes on. It just sits down there in total blackness, untouched, basically forever. Now, you might be thinking, okay, it's deep, it's big, but we've got submarines, we've got robots, we send probes into space. Surely we just zip down there whenever we want and check it out. And this is where things get genuinely humbling, because the answer is no. We almost never go. And the reason we almost never go is the single most hostile thing about that place. The thing that makes it more dangerous than the surface of the moon. The pressure. Let me explain pressure, because this is the part that turns the Challenger Deep from a cool geography fact into something that feels like a horror movie. When you go underwater, the weight of all that water above you presses down on you. You feel a little of this in a swimming pool, that pressure on your ears when you dive to the bottom of the deep end. Now imagine 11 kilometers of water stacked on top of you. The pressure at the bottom of the Challenger Deep is roughly 1,000 times the pressure you're feeling right now, sitting wherever you are. And the way scientists describe it, the way that actually makes it land in your gut, is this. It's like balancing a 1-ton weight on the surface of your thumbnail. 1 ton. On an area the size of your thumbnail. Pressing down. Constantly. Everywhere. And here's the crazy part. That kind of pressure doesn't just make things uncomfortable. It crushes living cells. It is enough force to literally dissolve bone. Think about what that means. A normal animal, a normal creature, anything built the way you and I are built, would not be squished, it would be erased. The pressure is so extreme that the chemistry of your body, the calcium in your skeleton, the structures inside your cells simply cannot hold together. The place is actively hostile to the basic idea of being alive in the form you understand life. And if you think that's just a problem for soft, squishy humans, let me give you the moment that really proves how brutal this is. In 2014, scientists built a vehicle specifically to survive down there. This wasn't some flimsy experiment. This was an unmanned machine, no people inside, engineered from the ground up for one job: to withstand the pressure at the bottom of the deepest trench on Earth. They built it to take the punch, and the trench punched back. Down there, the pressure imploded it. The thing that was custom-made, specifically designed, purpose-built to survive that exact pressure, got crushed anyway. Imagine spending all that time, all that engineering, all that money, building the one tool meant to handle the deep, and the deep just folds it like a soda can. That's what you're dealing with. That's the opponent. Now let me put the human side of this in perspective, because the numbers here are absolutely wild, and they tell you everything about how little we've actually done. You'd assume that the bottom of our own ocean, a place on our own planet, would be one of the most visited extreme spots, right? It's right here. It's not in space. It's not on another world. It's down the road, cosmically speaking. So how many people have been to the bottom? More people have stood on the moon than have stood at the bottom of the Challenger Deep. Let that sit for a second. We are talking about a place on Earth, our home, our backyard, and fewer humans have visited it than have visited a literal celestial body 250,000 miles away. And it gets even more lopsided when you stack up the numbers side by side. Nearly 7,000 people have climbed Mount Everest. 7,000. There are literal traffic jams on Everest now, lines of people waiting their turn near the summit. 12 people have walked on the surface of the moon. 12 human beings have stood on another world and looked back at Earth. And the bottom of the Challenger Deep? After the very first descent happened in 1960, almost nobody went back. For half a century, 50 years. The deepest point on our own planet got reached once, and then we basically just shrugged and walked away for 5 decades. Think about how strange that is. We poured incredible effort, money, and ambition into climbing to the highest places and flying to other worlds. But the deepest place right underneath us, we touched it and then ignored it for 50 years. And the reason is exactly what we just talked about. It is so hard, so dangerous, so expensive, and so unforgiving that for the longest time it just wasn't worth the risk. Going to the bottom of the ocean is, in some ways, a harder problem than going to the moon. Now let me take you back to that very first descent, because it is one of the most insane stories in the history of exploration, and almost nobody knows the details. The year is 1960. 2 men climb into a vessel and begin lowering themselves into the Challenger Deep. They are going where no human has ever gone, down into a place where the pressure can dissolve bone and crush cells, and they are doing it with 1960s technology. No computers like we have, no modern materials, just steel, glass, nerve, and a willingness to gamble their lives on the bottom of the world. And as they're going down, deeper and deeper, with kilometers of black water pressing in from every side, something happens that should have been the end of them. About 9 kilometers down, a window cracks, and not a quiet little hairline crack. The way it's described, there was an almighty bang, a sound like an explosion inside the vessel, this violent crack ringing through their tiny pressurized world, 9 kilometers beneath the surface, with thousands of meters of water still above them, and the whole crushing weight of the ocean looking for any tiny weakness to exploit. Now here's where you and I would lose our minds. A window just cracked. You're 9 kilometers down. The one thing standing between you and being instantly flattened into paste is the integrity of that vessel, and you just heard it bang like a gunshot. What do? You go up, obviously. You abort. You get out of there as fast as physically possible, and you thank whatever's out there that you're still breathing. That is not what these 2 men did. They kept going. They kept descending, another 3 kilometers down, into the deepest part of the deepest place on the planet, with a cracked window. And here's the part that makes it almost unbelievable, the part that turns it from brave into something else entirely. They didn't fully understand what had happened. They didn't realize that one of the things keeping them from imploding had just failed. They heard the bang, they noted it, and they pressed on into the abyss, not grasping that the margin between them and death had just gotten thinner. They rode that cracked vessel all the way to the bottom, basically not knowing how close they'd come to never coming back. And that's why those 1960 pioneers are legends, not because they were fearless, but because they pushed into the unknown, even when the unknown was actively trying to kill them and they couldn't even tell how badly. And that, right there, is the whole story of the deep ocean in miniature. It is a place that punishes every attempt to understand it, that hides its dangers until they're right on top of you, that lets you in just barely and never lets you forget how unwelcome you are. So with all of that working against us, you might wonder, when we do manage to get down there, when we do scrape together a look at the bottom, what do we actually find? Is it just an empty, dead black desert? A flat plain of mud with nothing living, nothing moving, just cold and crushing nothing. That's what you'd expect. No sunlight, no warmth, pressure that dissolves bone. Surely nothing could live there. And that's exactly the assumption I want to flip on its head, because the truth turns out to be so much weirder and so much more alive than the dead wasteland you're imagining. Let me explain. Up here, in the world you and I live in, basically all life runs on sunlight. The whole food chain, top to bottom, traces back to the sun. Plants soak up sunlight and turn it into energy. Then things eat the plants. Then things eat those things, all the way up. Sunlight is the battery that powers nearly everything alive on the surface. It is the foundation of the entire system. Take away the sun and the whole thing collapses. Now go down to the bottom of the Challenger Deep. There is no sunlight. Not a single photon from the sun has ever reached that far. It is total, absolute, permanent darkness. The kind of dark that has never once in the entire history of the planet been broken by daylight. So, by the logic of the surface world, nothing should be able to live. No sunlight, no energy, no food chain, no life, right? Wrong. Because down there, life found a completely different way to power itself. Life down in the deep doesn't run on sunlight. It runs on chemistry. And this is honestly one of the most mind-bending things I've ever come across. The idea that there's a whole second blueprint for life on this planet. One that doesn't need the sun at all. One that's been quietly humming away in the dark this entire time, while we walked around up top thinking the sun was the only game in town. Here's how it works. Scattered across the deep ocean floor, there are volcanic vents, cracks in the seabed where heat and chemicals leak up from inside the earth. And out of these vents comes a chemical called hydrogen sulfide. To you and me, hydrogen sulfide is poison. It's the stuff that smells like rotten eggs. It's toxic. If you got a strong enough whiff in the wrong setting, it could kill you. It is not food. It is the opposite of food. And yet, down in the deep, there are microbes, tiny living organisms that feed on it. They take this toxic chemical pouring out of volcanic vents and they turn it into energy. They eat the poison. That's their sunlight. That's the bottom of their food chain. Not a star 93 million miles away, but chemical fumes leaking out of a crack in the bottom of the ocean. And once you've got that foundation, that chemical battery, you can start building life on top of it. And the life that gets built down there does not look like anything you're used to. Let me give you one example that genuinely stopped me cold when I first heard it. Down in the deep, there are single-celled organisms that grow to the size of a football. A football, one cell. Now think about that. The cells in your body are microscopic. You can't see a single human cell with your naked eye. You need a microscope. Cells are supposed to be invisibly tiny, the smallest building blocks of life. And down there, in the most hostile environment on the planet, where the pressure should crush everything, there are single cells you could pick up and hold in your hand. One cell, the size of a football. That's not just weird, that's a completely different idea of what a living thing can even be. And it keeps going. There's a volcano down in that region that holds something so strange, so genuinely alien, that we've only ever found anything like it in one other place, and that other place is not on Earth. This underwater volcano contains a pool of molten sulfur. Liquid, molten sulfur just sitting there in a pool at the bottom of the ocean. And as far as we know, the only other place in the entire solar system where you find a pool of molten sulfur like this is on a moon of Jupiter. Let me say that again so it lands. There is a feature at the bottom of our ocean that is so exotic, so unlike anything else on Earth, that the closest match we've ever found for it is on a moon orbiting Jupiter, hundreds of millions of kilometers away. We had to look at another world to find a twin for something that's sitting right here on our own planet, just under a few kilometers of water. That's how alien the deep is. It's got pieces of other worlds hidden inside it. And this is the part where it really clicks, right? This is why I said at the very start that we know less about the bottom of the ocean than about the surface of Mars. Because when we go down there, even in the tiny handful of times we've managed to go, we keep finding things that belong on other planets. Molten sulfur from a moon of Jupiter, cells the size of footballs, life that runs on poison instead of light. It's not that the deep ocean is empty, it's that the deep ocean is full of things so strange that our whole understanding of biology, of chemistry, of what counts as normal just falls apart down there. It is a genuinely alien world, and it happens to be on our own planet. Now, here's where I have to be honest with you about something, and it's the part that really reframes this whole thing. You'd think, given everything I just told you, that scientists have cataloged thousands and thousands of bizarre creatures down there, right? All this alien life, surely we've got a huge encyclopedia of it by now. So let me hit you with the actual number and brace yourself, because it's tiny. In the deepest zone of every ocean on Earth, combined, all of it, the very deepest parts of every single ocean on the entire planet added together, we have identified only about 400 species. 400. That's it. That's the grand total. Across every ocean, in the deepest zones, 400 known species. And to give you a sense of how pathetically small that number is, that's fewer species than you'd find in a single freshwater lake. One lake, a regular lake, somewhere out in the world, with its fish and its bugs and its plants, can have more identified species than the deepest zones of all the oceans on Earth put together. That is wild when you stop and think about it. The deep ocean covers an enormous portion of the planet. It's vast beyond comprehension. And our entire catalog of life from the deepest parts of it adds up to less than what's swimming around in some lake you could walk around in an afternoon. It's not because there's nothing down there. We just saw there's incredible stuff down there. It's because we have barely looked. We've taken the tiniest sample, peeked through the tiniest keyhole, and the 400 species we know about are just whatever happened to wander past that keyhole while we were looking. The real number, the actual amount of life down there, is almost certainly enormous. We just haven't met it yet. And this brings me to the most honest, most humbling part of this whole story, which is how we actually do this so-called exploration. Because in your head, when you picture deep-sea science, you're probably imagining something high-tech. Sleek submarines with bright lights gliding over the seabed, robotic arms gently collecting samples, cameras sweeping across alien landscapes, cinematic, advanced, futuristic. The reality is a lot more humble than that, and honestly a lot funnier and a lot more sobering at the same time. A huge amount of what we know about the deepest places comes from, basically, tying a dead fish to a pole. I'm not kidding, that's a real method. You take a dead fish, you attach it as bait, you lower it down to one single spot on the bottom, and then you film whatever swims up to investigate. That's it. That's a big chunk of our exploration of the deepest place on Earth. Drop some bait, point a camera, see what shows up for the free meal. Whatever creatures happen to be nearby and happen to be hungry and happen to swim into frame, those are the ones we learn about. Everything else, everything that wasn't hungry, wasn't nearby, wasn't interested in our dead fish, stays completely invisible to us. And when you really sit with that, you realize the actual question here isn't what did we find? The question is everything we're not seeing. Because think about the method. You drop bait at one spot, a single point on the floor of an area that is unimaginably huge. To put a number on that hugeness, we're talking about an area roughly 700 times bigger than the Grand Canyon. 700 times. And our strategy for understanding all of it is to drop a dead fish at one little spot and film the dinner guests. It's like trying to understand an entire continent by setting up one camera in one back alley and assuming whatever walks by represents everything that lives on the whole landmass. You'd capture a sliver, a rounding error, a nothing. That's where we are with the deep ocean. The 400 species we've identified aren't the inventory of what lives down there. They're just the ones that came to the keyhole. And the truth is, the deep is so vast, so dark, so hostile, and so underexplored that we are almost completely blind to it. We've got our cracked window, our dead fish on a pole, our one imploded robot, and our 12 versus nearly 7,000 head count. And out of all that, we've pieced together this faint, flickering, incomplete picture of an alien world that's been right under us the entire time. And now, let me really drive home why this matters and why it's so strange. We live on a planet where we've mapped the surface of Mars in detail. We've got rovers crawling across Martian dirt, sending back high-resolution photos, sampling rocks, analyzing the soil. We can pull up images of another planet's surface on a screen. And yet the bottom of our own ocean, the Challenger Deep, the Mariana Trench, the deepest zones of all our seas, remain darker to us, in terms of real knowledge, than that distant red world. We know the shape of Martian mountains better than we know the shape of life 11 kilometers beneath our own waves. Think about how backwards that sounds. The deep ocean is closer. It's reachable in hours, not months. It's on our own planet, the place we evolved on, the place we've lived our entire existence as a species. And it's more mysterious to us than another planet. That's not because we're lazy. It's because the deep is just that hard. The pressure that dissolves bone, the darkness that's never seen the sun, the cost, the danger, the way it crushes the machines we send and cracks the windows of the vessels we ride down in. Every single attempt to look is a fight, and we've only won that fight a handful of times. And here's what I keep coming back to. Every time we have managed to look, even with our pathetic dead fish on a pole, even through our cracked little windows, even with robots that get crushed for their trouble, we have found something extraordinary. Life that runs on poison instead of sunlight. Single cells the size of footballs. Microbes feeding on toxic chemicals from volcanic vents. Pools of molten sulfur that match nothing on Earth except a moon of Jupiter. A whole second blueprint for life, hiding in the dark, completely independent of the sun that everything up here depends on. If that's what we find with the tiniest, clumsiest peak, imagine what's actually down there. Imagine the full scale of it. 400 species is what we've met. What's the real number? How many football-sized cells? How many poison-eating microbes? How many creatures we've never imagined are living and dying in that crushing black right now, in an area 700 times the size of the Grand Canyon, while we sit up here thinking we understand our own planet? We don't. Not even close. We understand the thin, sunny skin of it, the part with light and air, and we've barely scratched the surface of the rest. And that, when you really chew on it, is the most incredible thing about the Challenger Deep. It's not just the depth, though the depth is staggering, deep enough to swallow Everest with 2 kilometers to spare. It's not just the pressure, though the pressure is monstrous, a ton on your thumbnail, enough to fold a purpose-built robot like paper. It's not even the alien life, though the alien life is unreal. It's the fact that all of this, all of these wonders and horrors and impossible creatures, exist in a place we have essentially never been. The deepest, strangest, most hostile, most alien environment in our entire reach. And it's right here, under the water, on the same planet where you're sitting right now, watching this, completely surrounded by an ocean we still barely understand. The bottom of the world has been waiting down there the whole time, mostly unseen, mostly unvisited. More people on the moon than at its floor. A window cracking with an almighty bang, and 2 brave fools descending anyway. A robot built to survive it, crushed by it. And 400 species standing in for the unknowable multitudes we haven't met. We keep calling ourselves explorers, but when it comes to the deepest place on Earth, the truth is, we've barely lifted the lid. And every single time we do, the deep reminds us just how little we actually know about the planet we call home. So, the next time you hear someone mention the Mariana Trench like it's just another fun fact, remember what's really down there. Remember that we know less about it than about Mars. Remember the cracked window, the imploded robot, the football-sized cells, the molten sulfur straight out of a Jupiter moon. And remember that the 400 species we've named are just the few that wandered past our keyhole, while everything else, the real bulk of that hidden world, stays in the dark, in an area 700 times the Grand Canyon, completely beyond our sight. Turns out the most alien place we know of isn't out in space at all. It's right here, under the waves, and we've barely even looked. Okay, so now I want to take you somewhere even stranger, because we've talked about how deep the Challenger Deep is and how brutal the pressure is, but we haven't really sat inside the experience of actually going down there. And I think the only way to make this hit is to put you in the vessel yourself. So let's do that. Let me explain what it would actually be like. Picture this. You're climbing into a tiny sphere, not a roomy submarine, not some spacious cabin with windows all around. A sphere barely big enough to hold you, with thick metal walls and one small viewport. The whole thing is built around a single principle, that a sphere is the strongest possible shape to resist crushing pressure, because the force gets distributed evenly across the whole surface, instead of finding a weak, flat panel to punch through. So you're not sitting in a vehicle, really. You're sitting inside a pressure-resistant ball, hoping the math holds. And the hatch closes above you, and you hear it seal, and now there's no getting out until you come back up. That's the deal. You're committed. and then you start to sink. At first, it's bright. The water near the surface is lit up, blue and alive. You can see fish, you can see light dancing through the waves above you. This is the part of the ocean you know, the part documentaries love, the part with color. But it doesn't last. As you go down, the light starts to drain away, color by color. Red disappears first, then orange, then yellow. The world turns blue, then deep blue, then a kind of bruised navy, and then, somewhere around a couple 100 meters down, it goes. All of it. The last of the light from the surface gives up, and you are in the dark. Not dim, dark. The kind of black that has no edges, where your eyes strain and find absolutely nothing, where the only light in the entire universe is whatever you brought with you. And here's the thing that gets people. You are nowhere near the bottom yet. You've barely started. You've been falling through black water for what feels like forever, and you've still got kilometers to go. The Challenger Deep is roughly 11 kilometers down, 11,000 meters. When you lose the light at a couple 100 meters, you've completed less than 2% of the journey. 98% of your descent happens in total darkness, in a place where the pressure is climbing every single second, where every meter you drop adds more crushing weight to the walls of your little sphere, and you just keep going, and going, and going, down into a black that has never, not once in the history of the planet, been touched by the sun. Now, while you're falling through all that black, let me explain something about the water itself, because it's not the same water top to bottom. It's not just one big bathtub. The ocean is layered, like a cake, and each layer is its own world with its own rules. Up top, you've got the sunlit zone, where there's light and warmth and most of the life you've ever seen or eaten. Below that, the light fades into a twilight zone, where there's just barely enough glow to see, a gloomy in-between. And below that, the light is completely gone, and you enter the midnight zone, where it's permanently, absolutely dark. And then you keep going into the deepest layers, the abyss, and then the trench zones, the Hadal Zone, named after Hades, the underworld, because that's genuinely what it is. The underworld, a place named after hell. And as you descend through these layers, the temperature drops too. Near the surface, the water might be warm, pleasant, the kind of water you'd swim in. But down in the deep, it's just above freezing, cold, crushing, and black. Three things all at once, all working against the idea of life, all working against you and your little sphere. Cold enough to kill, dark enough to blind, and pressure heavy enough to dissolve bone. That's the trinity of the deep. That's what's waiting at the bottom. And you're falling straight into it, voluntarily, in a metal ball. Now here's where it gets even more interesting, because you'd think with all that darkness, life would just be invisible. If there's no light, what's the point of being able to see, right? But the deep has an answer to the dark, and it's one of the most beautiful and eerie things in all of nature. The creatures down there make their own light. It's called bioluminescence, and a staggering number of deep-sea creatures have it. They glow. In the blackest place imaginable, where the sun has never reached, life learned to carry its own lanterns. Some glow to attract prey, dangling a little light like a lure to draw curious creatures close enough to eat. Some glow to find mates in the dark. Some glow to confuse predators, releasing a burst of light and then darting away while whatever was chasing them is dazzled. The deep isn't just dark. It's dark with little flickers of living light moving through it, a whole secret light show happening in a place almost no human has ever witnessed in person. And that's the wild contradiction of the deep ocean. It is the most lifeless-looking place you could imagine. Total dark, crushing cold, and yet it's threaded through with these glowing, glittering creatures that evolved an entire strategy around making light in a world that has none. It's like nature looked at the most hostile environment on the planet and said, "Fine, we'll bring our own light, we'll bring our own food source, we'll bring our own everything, and we'll live here anyway." Life is relentless like that. It doesn't ask whether a place is friendly, it just finds an angle and moves in. Now, let me bring you back to your sphere, because you've been falling this whole time and you're getting close to the bottom. And here's a detail that I think really captures how alien this is. As you approach the seafloor, after kilometers of empty black water, your lights finally catch the bottom. And what do you see? Not rock, mostly, not coral. You see this soft, pale, almost ghostly floor, made up of fine sediment that's been drifting down from above for millions and millions of years. This stuff is sometimes called marine snow, this constant, gentle fall of tiny particles, bits of dead organisms and waste and dust, drifting down from the world above like a slow blizzard that never stops. It's been falling for as long as the ocean has existed, settling layer on the bottom, building up this incredibly soft, deep, fine floor that your lights illuminate as you finally arrive. And it's so quiet down there. It's so still. The bottom of the Challenger Deep is one of the most undisturbed places on the entire planet. No storms reach it, no waves, no seasons, really. No day and night, because there's no sun to mark them. It's just an eternal, freezing, black, silent plain, with marine snow drifting down forever, and the occasional flicker of something glowing, and the immense pressure pressing in on everything. It is, in the most literal sense, another world. You could not design a place more different from the surface you live on if you tried. Now let me go back to that question of life down there, because I told you about the football-sized cells and the poison-eating microbes, but I want to talk about the bigger creatures too, the things that actually swim around in that crushing dark, because they are deeply, deeply strange. The deep sea is full of animals that look like they were designed by someone who had only ever heard a description of a fish and never actually seen one. Bodies that are mostly mouth, teeth that are too big to fit inside, jutting out at weird angles, eyes that are enormous to catch every scrap of that precious bioluminescent light, or eyes that are tiny or gone entirely, because in total darkness, what's the point? Bodies that are soft and gelatinous, because rigid structures are harder to maintain under that kind of pressure. Everything about them is shaped by the deep, sculpted by the dark and the cold and the crushing weight, into forms that look nothing like the life up here. And here's the crazy part about how these animals survive the pressure. You and I would be crushed because we're full of air and we have rigid structures, bones and cavities and gas-filled spaces that the pressure would collapse. But deep-sea creatures have basically gotten rid of all of that. Many of them have no air spaces at all. Their bodies are full of water and soft tissue, and water doesn't compress the way air does, so the pressure can press in all it wants and there's nothing to collapse. They've also changed their bodies at the chemical level, the molecular level, in ways that let their proteins and cells keep functioning under pressure that would tear ours apart. They are not just tough versions of surface animals. They are fundamentally re-engineered for a different physics. They live in a world where the rules of pressure are completely different, and they've rebuilt themselves from the inside out to match it. And this is one of the things that makes deep-sea biology so valuable and so mind-bending. These creatures have solved problems that we, with all our technology, still struggle with. We build a robot to survive the pressure, and it implodes. Meanwhile, a soft little gelatinous animal with no bones and no metal and no engineering team just swims around down there like it's nothing, perfectly adapted, completely at home in a place that crushes our best machines. Nature got there first, and nature got there better. There's something humbling about that. We think of ourselves as the masters of technology, the species that conquers every environment, and yet a blob of jelly in the dark has solved the deep ocean in a way we still can't fully replicate. Now, speaking of how creatures survive down there, let me bring back those volcanic vents I mentioned, because they deserve a closer look. These vents, these cracks in the seabed where heat and chemicals leak out from inside the earth, are like oases in the deep. In the vast, empty plains of the abyss, where food is scarce and life is thin, these vents are explosions of life. Whole communities cluster around them, because around the vents, that chemical energy is abundant. The microbes that eat hydrogen sulfide thrive there, and then bigger creatures gather to eat the microbes, or to host them. And suddenly, you've got these thriving, bustling ecosystems in the middle of nowhere, powered entirely by chemistry, entirely by the heat and chemicals of the planet's interior, completely cut off from the sun. And this discovery, when it first happened, genuinely rewrote what scientists thought was possible. Before we found these vent communities, the assumption was simple. Sunlight powers life. No sunlight, no life. That was the rule. And then we sent vehicles down to these deep vents and found them swarming with creatures, thriving, abundant, in total darkness, with no connection to sunlight at all. It was a revelation. It meant that life didn't actually need the sun. It meant that the fundamental energy of life could come from chemistry, from the raw chemicals of a planet, not just from a star. And that one realization completely changed how we think about where life could exist. Because here's the leap. If life on Earth can power itself on chemistry instead of sunlight, deep in the dark, around volcanic vents, then maybe life elsewhere in the universe could do the same. Maybe you don't need a sunny planet at the perfect distance from its star. Maybe you just need liquid water and chemical energy. And suddenly, all these places that we'd written off as dead, places like the ice-covered moons of Jupiter and Saturn, started to look a lot more interesting. Because some of those moons are believed to have oceans of liquid water hidden under their icy shells, and some of them likely have volcanic activity at the bottom, exactly the kind of setup that powers life in our own deep ocean. The discovery at the bottom of our sea opened up the possibility of life across the entire solar system. And remember what I told you earlier about that pool of molten sulfur at the bottom of our ocean that matches nothing on Earth except a moon of Jupiter? Now you can see why that connection is so electric. We are finding, at the bottom of our own ocean, conditions and features and chemistry that mirror what we think exists on other worlds. The deep ocean is, in a very real sense, our best laboratory for understanding alien life, because it's the closest thing to an alien world that we can actually reach. We can't go to a moon of Jupiter, not yet, but we can, barely, with enormous effort, go to the bottom of the Challenger Deep, and when we do, we find pieces of those distant worlds staring back at us. That's the thing that makes this whole story so much bigger than just one deep trench in the Pacific. The deep ocean isn't just a record of our own planet's mysteries. It's a preview of the universe. Every football-sized cell, every poison-eating microbe, every glowing creature in the dark, every pool of molten sulfur is teaching us something about what life can be, where it can survive, and how it might exist far beyond Earth. We went looking down into our own ocean, and we ended up learning about the stars. Now let me pull you back to the harsh practical reality again, because I don't want to make it sound like we've got this all figured out. We don't. Remember, we've identified about 400 species in the deepest zones of all the oceans combined, fewer than you'd find in a single freshwater lake. And remember the method: the dead fish on a pole, the camera at one spot, the area 700 times the size of the Grand Canyon that we're trying to understand by peeking through a keyhole. The truth is, every single thing I've just described to you, the bioluminescence, the gelatinous bodies, the vent communities, the football-sized cells, all of it comes from an absolutely tiny sample of an absolutely enormous place. We are working with scraps, glimpses, flashes in the dark, and that's what makes the deep ocean simultaneously the most explored and least explored place, depending on how you look at it. We've technically been there, we've technically seen it. We've got footage, samples, discoveries. But the proportion of it we've actually examined is so vanishingly small that for all practical purposes, it's still unknown. Imagine if humanity's entire knowledge of the surface of the Earth, all the continents, all the cities, all the forests and deserts and mountains, came from a handful of photographs taken at a few random spots. You'd know almost nothing. You'd have these isolated snapshots and a vast, vast unknown in between. That's where we are with the deep. A handful of snapshots and an ocean of mystery. And you have to remember how recently a lot of this even became possible. For most of human history, the deep ocean was completely, totally beyond reach. People used to think the deep sea was a dead zone, a lifeless desert, because how could anything survive down there? There was even an old idea, taken seriously for a while, that below a certain depth there was simply no life at all, a barren void. The deep was a blank on the map, a place sailors feared, a place full of imagined monsters precisely because nobody actually knew what was down there. And in a way, the imagined monsters weren't even that far off, because what's actually down there, the football cells, the glowing lure fish, the vent creatures, is stranger than most of the monsters people invented. Let me put the timeline in perspective for you, because it really drives home how new all of this is. That first descent to the bottom of the Challenger Deep, the one with the cracked window and the almighty bang, happened in 1960. That's not ancient history. There are people alive today who were already adults when it happened. And then, after that dive, almost nobody went back for about half a century. 50 years of essentially leaving the deepest place on Earth completely alone. It's only relatively recently that we've started seriously going back, building new vehicles, sending down new expeditions, actually trying to study the place instead of just touching it once and retreating. In the grand scheme of human history, our real exploration of the deep ocean is just barely getting started. We are, right now, in the earliest infancy of understanding the largest habitat on our own planet. And that's a strange thought, isn't it? We tend to feel like we've discovered everything, like the age of exploration is over, like all the maps are filled in, like there's nothing left to find. We've been to the poles, we've climbed the highest peaks, we've crossed every desert, we've mapped Mars from orbit. The world can feel small and known and used up, but it's not. Because right beneath the surface of the ocean, covering most of our planet, there's a frontier as wild and unknown as anything the old explorers ever faced. More unknown, honestly. The early explorers at least knew there were continents out there. With the deep ocean, we genuinely don't know what we'll find, because every time we look, we find something we didn't expect. Now I want to take you back into that scene one more time, because I think it's worth really feeling. You're in your sphere. You've fallen through 11 kilometers of black water. Your lights are on the bottom now, illuminating that soft, pale floor, that ancient sediment that's been drifting down for millions of years. The pressure outside is monstrous, a ton on your thumbnail, enough to dissolve bone, pressing in on every square centimeter of your little sphere. And you are, in this moment, one of the only humans in all of history to be here. Fewer people have been where you are than have walked on the moon. You're looking at a landscape that almost no one has ever seen with their own eyes. It's silent, it's still, it's cold. The marine snow drifts gently down through the beam of your lights. And somewhere out there in the dark, just beyond what your lights can reach, things are living. glowing, feeding on chemistry, surviving in a way that should be impossible. That's the deep. That's what's down there, right now, as you're listening to this. It hasn't gone anywhere. The Challenger Deep is sitting in the Western Pacific at this exact moment, 11 kilometers down, pitch black, freezing, crushing, full of alien life, and almost completely unwatched. There's no camera crew down there right now. There's no expedition. There's just the deep, doing what it's done for hundreds of millions of years, keeping its secrets, waiting. And here's what gets me about all of this, the thing I keep circling back to. We spend so much energy looking up. We point telescopes at distant galaxies. We send probes to other planets. We dream about Mars and the stars and what might be out there in the void. And all of that is incredible. I'm not knocking it. But the most alien place we've ever found, the strangest, most hostile, most surprising environment we know of, the one with creatures that match moons of Jupiter and life that runs on poison and cells the size of footballs, that place is down, not up, down, right beneath us. Under the water we sail across and swim in and fly over without a second thought. The aliens we've been searching the heavens for might have closer cousins at the bottom of our own ocean than anywhere in the sky. And we've barely looked. That's the part that should keep you up at night, in the good way. 400 species, a dead fish on a pole, a handful of dives, an area 700 times the Grand Canyon explored through a keyhole. The deepest place on Earth, the most extreme environment we can reach, and we've seen almost none of it, which means almost everything is still out there, undiscovered, unnamed, unseen. An entire hidden world on our own planet just waiting for us to finally, properly, go and look. So as we keep going, I want you to hold on to that feeling, the feeling that we are not done, the feeling that the biggest discoveries might not be a billion light years away, but 11 kilometers straight down. Because the deep ocean is the closest thing to another world that we will ever be able to touch. And we are only just beginning to understand what's been living in the dark beneath us this entire time. Now, let me back up for a second and ask you a question you've probably never actually thought about, even though it's wild. How do we even know the Challenger Deep is the deepest point on Earth? Like, think about it. It's 11 kilometers down. It's pitch black. It's crushing. Almost no one's been there. So how did anyone ever figure out, hey, this specific spot in the Western Pacific is the lowest point on the entire surface of the planet? You didn't just stumble onto it. You can't see it. You can't walk the bottom with a measuring tape. So how? And the answer to that is a story in itself, and it goes back way further than that 1960 dive. Because long before anyone ever physically went to the bottom, people were trying to measure it. And the early methods were honestly kind of charming and kind of insane. The original way to measure ocean depth was the simplest thing you can imagine. You took a long rope, you tied a weight to the end, and you dropped it over the side of a ship and let it sink until it hit the bottom. And then you measured how much rope went out. That's it. That's how humanity started mapping the deep. A weight on a rope. It's almost funny, the idea of trying to measure the deepest place on Earth, 11 kilometers down, by lowering a rope off the back of a boat. Imagine how much rope. Imagine standing on deck, feeding out kilometer after kilometer of line into the black water, waiting, waiting, waiting for the weight to finally touch something. And that's actually connected to the name. The Challenger Deep gets its name from a ship, a vessel called the Challenger, that went on a famous expedition in the 1870s to study the oceans. This was one of the first serious attempts to scientifically explore the deep sea, and the crew spent years sailing around the world taking measurements, dropping their lines, hauling up samples, cataloging creatures, basically inventing the entire science of studying the ocean as they went. And it was during this expedition, in that region near the Mariana Islands, that they took soundings showing the water there was extraordinarily, shockingly deep. So that spot, the deepest point, got named after the ship that first revealed it, the Challenger Deep, named after a wooden sailing ship from the 1800s that found the bottom of the world with a weighted rope. Now, obviously, we don't use ropes anymore. The modern way we measure the deep is with sound, and this is genuinely clever. It's called sonar. You send a pulse of sound down through the water, and that sound travels down, hits the bottom, and bounces back up to your ship. And because you know how fast sound travels through water, you can measure exactly how long it took for the sound to make the round trip. And from that, you can calculate precisely how deep the water is. Send a ping, time the echo, do the math, and you've got the depth. And by doing this over and over, across an area, sweeping back and forth, you can build up a map of the seafloor without ever physically going down there. You're basically feeling out the shape of the bottom with sound, like a bat using echolocation in the dark, except the dark is 11 kilometers of black ocean. And that's how we know the Challenger Deep is the deepest. We've pinged it, measured it, mapped it with sound, confirmed it again and again. But here's the thing, and this is important. Mapping the shape of the bottom with sound is a completely different thing from actually exploring it. Knowing the depth of a place tells you nothing about what lives there. Sonar can tell you the floor is 11 kilometers down. It can't tell you there are football-sized cells, or glowing creatures, or pools of molten sulfur, or any of it. For that, you actually have to go. You have to send something down, a vehicle, a camera, a person, into the crushing dark. And that's the part we've barely done. Which brings up one of the most mind-blowing facts about our planet, and it's the kind of thing that sounds made up but is completely true. We have better maps of the surface of the Moon and Mars and even Venus than we have of the floor of our own ocean. Let that sink in. We have mapped distant worlds, planets, and moons across the solar system in more detail than the bottom of the sea on the planet we actually live on. The reason is exactly what we just talked about. Up in space, you can map a whole planet's surface from orbit because light and radar travel freely through the vacuum of space, and you can photograph and scan the entire surface from far away. But water blocks all of that. Light doesn't penetrate the deep. You can't photograph the seafloor from a satellite because the ocean is in the way. The only way to map the deep in real detail is to drag sonar equipment across it, ship by ship, line by line, which is slow and expensive and covers a tiny area at a time. So vast stretches of our own ocean floor have never been mapped in any real detail at all. They're blanker on our maps than the surface of Mars. Think about how backwards that is. A robot on Mars has photographed Martian rocks up close. We can pull up detailed maps of craters on the Moon. But there are huge regions of our own seafloor that we've never properly seen, where we have only the roughest idea of the shape of the bottom, let alone what's down there. The deep ocean is the single biggest unmapped, unexplored region on the entire planet, and it's right under us, and we know it less well than other worlds. Every single time I come back to that fact, it hits me fresh. We are surrounded by the unknown, and the unknown is wet and dark and deep and right beneath our feet. Now, let me explain why this actually matters, because you might be thinking, okay, cool, it's deep and mysterious, but so what? Why should anyone care about a black, freezing trench at the bottom of the Pacific that almost nobody will ever visit? And the answer is that the deep ocean is not some isolated, irrelevant corner of the planet. It's connected to everything. It affects you directly every single day, even though you'll never see it. Let me walk you through how. First, the ocean is the planet's climate engine. The deep ocean stores an absolutely staggering amount of heat and carbon. The seas absorb a huge portion of the heat that gets trapped by the atmosphere, and a huge portion of the carbon too, pulling it down out of the air and locking it away in the cold, dark depths. The deep ocean is, in a very real way, regulating the temperature of the entire planet. It's a giant buffer, soaking up heat and carbon, slowing down changes that would otherwise be far more extreme, far faster. And the currents that move through the deep, these slow, massive flows of cold water circulating around the entire globe, they redistribute heat across the planet, shaping climates and weather patterns all over the world. The deep ocean is not separate from the world you live in. It is quietly running the thermostat of the whole planet, and we barely understand it. We're depending on a system we can't even properly see to keep our climate livable. Second, the deep ocean is connected to the food you eat and the air you breathe. A massive amount of the oxygen on Earth comes from the ocean, from tiny organisms living in the water. And the deep plays a role in the great cycles of nutrients that feed life throughout the seas, including the fish that billions of people depend on for food. Those nutrients that drift down as marine snow, that sink into the deep, they get cycled back up through deep currents to feed life nearer the surface. The deep is part of the machinery that keeps the entire ocean alive, and the entire ocean is part of what keeps you alive. You breathe air that the ocean helped make. You eat food that the ocean's cycles help produce. And the deep, that black, crushing, unexplored zone, is woven right into all of it. Third, and this is one that's exploding in importance right now, the deep ocean is full of life that could be medically and scientifically priceless. Remember all those creatures that have re-engineered themselves to survive the impossible? The microbes that thrive on toxic chemicals, the organisms that function under crushing pressure, the life that lives at temperatures and conditions that would destroy anything from the surface. Those creatures have evolved chemistry that we have never seen before. Molecules and proteins and processes that don't exist anywhere up here. And that kind of novel chemistry is exactly where new medicines come from. Throughout history, some of our most important drugs have come from strange organisms in unexpected places. The deep ocean is potentially a treasure chest of unknown chemistry, compounds that could fight diseases, antibiotics we've never imagined, enzymes that could transform industry. And we've only cataloged 400 species in the deepest zones. 400. The number of potential discoveries we're sitting on top of and not looking at is almost incomprehensible. And here's the part that's bittersweet, because there's a darker side to this too. Even as we've barely explored the deep, we've already started to affect it. We've already reached down there with our impact, even in places we've never physically visited. Pollution finds its way to the deep. Tiny particles of plastic, the kind that break off from all the plastic waste in the world, have been found in the deepest parts of the ocean, in the very bottom of the trenches, in the bodies of creatures living down there. Think about that. The deepest, most remote, least visited place on Earth, a place fewer people have been than have walked on the moon, and our trash is already there. We managed to pollute the bottom of the Challenger Deep before we even properly explored it. We left our fingerprints on the deepest place on the planet without ever really getting to know it. And it goes further, because there's a growing interest in the deep ocean for a very practical, very money-driven reason. The seafloor, in certain places, is rich in valuable minerals and metals. There are these formations on the deep ocean floor, sometimes called nodules, lumps of metal-rich material that have built up over millions of years, full of the kinds of metals that go into batteries and electronics, the metals that modern technology runs on. And as the demand for those metals grows, there's more and more pressure to go down and mine the deep sea floor, to scrape up these resources from the bottom of the ocean. And that raises a genuinely huge question. Do we really want to start tearing up the deep ocean floor? An ecosystem we barely understand, full of life we've barely cataloged, before we even know what's down there. We might destroy entire species, entire ecosystems, things we never even discovered, never named, never studied, all to dig up metal. We could erase chapters of the story before we ever get to read them. That's the tension at the heart of the deep ocean right now. It's this incredible, alien, mysterious frontier, full of scientific and medical and even cosmic significance. And at the same time, it's this untapped resource that people want to exploit, and a place we're already accidentally damaging. And we're making decisions about it, real decisions with real consequences, while still knowing almost nothing about it. We're like someone deciding to bulldoze a library they've never been inside, in the dark, based on a handful of pages glimpsed by flashlight. It's a strange and risky position to be in. Now let me pull back to the wonder of it again, because I don't want to leave you on the heavy stuff. Let me explain just how much there might be down there, because the scale of what's undiscovered is genuinely staggering. Scientists estimate that the vast majority of ocean species have not yet been discovered. The 400 we've identified in the deepest zones are a rounding error against what's likely actually there. Every serious deep-sea expedition that goes down comes back with new species, creatures never seen before, things that have to be given names because they've never been recorded in all of human history. That's not a rare event. That's the norm. You go down, you look, you find something new. The deep is so underexplored that finding brand new forms of life is basically expected. Imagine that. Imagine a frontier so wild that discovering a creature unknown to science is just a regular Tuesday. And think about what that implies. If every expedition finds new life, and we've only done a tiny handful of expeditions, then the deep must be absolutely teeming with undiscovered species. Thousands of them, tens of thousands maybe far more. An entire hidden biosphere, a whole parallel kingdom of life, glowing and crawling and swimming and feeding in the dark, completely unknown to us. We share a planet with countless creatures we have never met and may never meet, living their entire lives in conditions we can barely survive for a few hours in a metal sphere. They've been there the whole time. While humanity built civilizations, fought wars, invented language, flew to the moon, those creatures were down in the deep, generation after generation, in the dark, doing their thing, utterly indifferent to the dry world above. There's something almost beautiful about that, and almost eerie. The idea that the planet has this enormous secret life, this whole population of beings we don't know about, hidden in the one place we can't easily go. It makes the Earth feel bigger again. It makes it feel mysterious again. We grow up being told the world is fully explored, fully mapped, fully known, that the age of discovery is over and there's nothing left to find. And that's just not true. The biggest unexplored region on Earth is right here, covering most of the planet, and it's so full of unknown life that we can't even estimate how much we're missing. Now let me take you back into a vessel one more time, because I want you to feel the human side of actually being there, the psychology of it, what it does to a person to descend into that place. Imagine you're the one going down. You've trained for this. You know the risks. You know about the cracked windows and the imploded robots and the ton of pressure per thumb. And you climb into your sphere anyway, and the hatch seals, and you start to sink. And for hours, you fall through the dark. Hours. It's not a quick trip. It takes a long time to descend 11 kilometers, slowly sinking through layer after layer of black water, watching your instruments, listening to the sounds of your vessel, feeling that you are getting further and further from the surface, from the air, from light, from rescue. If anything goes wrong down there, no one is coming to save you. You are more isolated than an astronaut, in some ways, because at least we can reach orbit. The bottom of the Challenger Deep is harder to mount a rescue to than space. And the silence, the waiting, the dark pressing in on your little viewport, the knowledge that the pressure outside is building with every meter, looking for any flaw, any weakness, any crack. It takes a particular kind of person to do that, to stay calm, to keep working, to keep observing and recording while sitting inside a metal ball at the bottom of the world with the entire weight of the ocean trying to crush you. The people who've made these dives are some of the bravest explorers in human history, and most people couldn't even tell you their names, because the deep ocean doesn't get the glory that space does. Nobody throws a parade for the bottom of the sea. But what these people did, descending into the most hostile, reachable place on the planet, is every bit as extraordinary as going to the moon. Arguably more, given how few have done it and how brutal the conditions are. And when you finally reach the bottom, after that long, dark, tense descent, what you get is a few precious hours. That's it. You can't stay long. The conditions are too extreme. The systems can only sustain you for so long. The whole operation is balanced on a knife's edge. So you get this tiny window, a handful of hours at the bottom of the world, to look around, to observe, to collect what you can, to be one of the only humans ever to witness this place with your own eyes. And then you have to leave. You drop your weights, you start to rise, and you ascend back up through all that dark, back toward the light, back toward the world of air and sun and people, leaving the deep behind you exactly as you found it. Silent, black, crushing, full of secrets you only barely glimpsed. And that's really the whole human relationship with the deep, isn't it? We get these tiny glimpses, these few precious hours, these flashes of light in an endless dark. And from those scraps, we try to understand a place that's bigger and stranger than almost anything else we know of. We're like someone trying to understand the night sky by being allowed to look up for just a few seconds, once every few years, through a tiny window. You'd see a few stars, you'd catch a hint of how vast it all is, and you'd spend the rest of your time wondering about everything you didn't get to see. That's the deep ocean. A few seconds of looking, a universe of mystery, and the constant, humbling reminder that the planet we think we know is still mostly unknown to us, still mostly dark, still mostly waiting. And the deepest part of it, the Challenger Deep, sits down there right now, exactly as it has for hundreds of millions of years, with its glowing creatures and its poison-eating microbes and its football-sized cells and its molten sulfur, keeping its secrets, while we sit up here in the light, only just beginning to understand the alien world beneath our own waves. Okay, so now I want to circle back to that first descent one more time, the 1960 dive, because there's a part of that story I haven't fully unpacked yet, and it's the part that I think captures the whole spirit of this. Picture those two men again. They've ridden their vessel all the way down, through the cracked window and the almighty bang, all the way to the bottom of the Challenger Deep, 11 kilometers below the surface. The first humans ever to reach the lowest point on the planet. And what do you think they saw when they got there, when they pointed their light at the seafloor in the deepest, darkest, most crushing place on Earth? They saw life. Right there, at the bottom, in a place where the pressure could dissolve bone, where no sunlight had ever reached, where everything we thought we knew said nothing could possibly survive, they reported seeing living things, movement, creatures at the very bottom of the world. And that single observation, made by two exhausted men in a cracked metal sphere in 1960, was the first hint of what we'd spend the next half-century slowly confirming. That life is everywhere down there, that the deep is not a dead void, that even the absolute deepest point on the planet, the worst possible place to be alive, has living things in it. They went looking for the bottom, and they found that life had already beaten them to it, had been there all along, thriving in the dark in a place humans could only barely visit. And that, when you really think about it, is the whole story of this planet in a single image. Two men in a fragile bubble at the bottom of the world, looking out at creatures that had been living there for longer than humans have existed, in conditions we can't survive, powered by chemistry instead of sunlight, glowing in the dark. We are the visitors. We are the strangers down there. The deep doesn't belong to us. It belongs to them. The football-sized cells and the poison eaters and the glowing hunters and the soft, pressure-proof bodies. And we just get to drop in for a few hours with the right equipment and a whole lot of luck, and take a peek before we have to run back up to the light. Now let me tie together everything we've covered, because when you stack it all up, the full picture is genuinely staggering. Start with the scale. The Challenger Deep is deep enough to swallow Mount Everest with 2 kilometers to spare, deep enough to hold 5 Grand Canyons in that one spot alone. The pressure at the bottom is like a 1-ton weight balanced on your thumbnail, enough to crush living cells and dissolve bone. Enough that in 2014 it imploded an unmanned vehicle built specifically to survive it. It is so hostile and so hard to reach that more people have stood on the moon than have stood at its bottom, that nearly 7,000 have climbed Everest and 12 have walked on the moon. But after that first descent in 1960, almost nobody went back for half a century. And despite all of that, despite the pressure and the cold and the dark and the sheer impossibility of the place, it's alive. Life down there runs on chemistry, not sunlight. Microbes feed on hydrogen sulfide pouring out of volcanic vents, turning poison into energy. Single cells grow to the size of a football, and one volcano down there holds a pool of molten sulfur found nowhere else in the entire solar system except a moon of Jupiter. An alien feature on our own planet, at the bottom of our own sea. And yet, for all that wonder, we've identified only about 400 species in the deepest zone of every ocean on Earth combined, fewer than you'd find in a single freshwater lake. And the brutal truth of how we even got that far is humbling, mostly tying a dead fish to a pole, dropping it at one single spot, and filming whatever swims up to investigate. That's our grand exploration of the deepest place on the planet. A dead fish and a camera at one little spot in an area roughly 700 times the size of the Grand Canyon. So when you put it all together, here's where we actually land. The real question was never, what did we find down there? The football cells, the molten sulfur, the glowing creatures, the poison-eating microbes, those are the things that happen to wander into our tiny circle of light. The real question, the one that should stick with you, is everything we're not seeing. Because if a dead fish on a pole at one spot reveals creatures that match moons of Jupiter, then what's out there in all the spots we've never looked? What's living in the 99.99% of the deep we've never illuminated? An entire world. A whole hidden kingdom of life, right here, on the planet you live on. In the dark, under the water, waiting. And I think that's the thing I really want you to walk away with. Not just that the deep ocean is cool, though it is. Not just that it's scary, though it is. But that it changes how you should think about the planet itself. We grow up with this feeling that the Earth is fully known. The maps are filled in, the explorers have all come home, there's nothing left to discover. And if you want real frontier, real mystery, real unknown, you have to look up, to space, to other planets, to the stars. And that's just not true. The greatest unexplored frontier on Earth isn't out there in the void. It's down, it's wet, it's dark, it covers most of the planet. And we know it less well than we know the surface of Mars. Think about your own life for a second. You've probably looked up at the night sky and felt that sense of vastness, that humbling feeling of how small you are against the enormity of space. But you've probably never stood at the edge of the ocean and felt that same thing, even though you should. Because right there, beneath that surface, beneath those waves you've watched 100 times, is a frontier just as vast and just as unknown, and arguably even more alien than the night sky, full of creatures stranger than anything we've imagined among the stars. The aliens we keep searching the heavens for might have their closest relatives at the bottom of our own ocean. We've been looking up the whole time, and the strangest life we've ever found was beneath our feet. And here's the hopeful part. The part that makes this an exciting time to be alive rather than just a humbling one. We are, right now, at the very beginning of finally exploring it properly. For most of history, the deep was completely out of reach. Then we touched it once in 1960 and walked away for 50 years. But now, the technology is catching up. We're building better vehicles, sending down better cameras, mapping more of the floor, mounting more expeditions. The age of deep ocean exploration isn't over, it's barely started. And that means the great discoveries are still ahead of us, not behind. Somewhere out there, right now, are creatures no human has ever seen, ecosystems no one has ever recorded, chemistry that could change medicine, clues about how life works and where else in the universe it might exist. All of it waiting in the dark for us to finally go and look. That's not a story about a frontier that's closed. That's a story about a frontier that's wide open, the biggest one left on Earth. And it's not in some unreachable place. It's right here, beneath the ocean, on the planet we've lived on this entire time without ever really getting to know it. There's something genuinely thrilling about that. The idea that the greatest age of discovery might not be in the past at all, but in front of us, downward, into the deep. So the next time you're standing on a beach, or looking out over the water from a boat, or even just flying over the ocean and glancing down at that endless blue from the window of a plane, I want you to remember what's actually down there. Remember that beneath that calm surface, kilometers below, there's a place darker and colder and more crushing than anywhere you'll ever go. Remember that it's full of life that runs on poison and glows in the dark and grows in shapes that shouldn't exist. Remember that there's a pool of molten sulfur down there that matches a moon of Jupiter, and cells the size of footballs, and microbes feeding on the breath of volcanoes. Remember that more people have been to the moon than to its deepest point, and that we've named only 400 of its creatures, and that almost everything down there is still completely unknown. The ocean isn't just water. It's the largest, deepest, darkest, least understood, most alien place within our reach, and it's been sitting beneath us, patient and silent this entire time. We've spent our history looking up at the stars and dreaming of other worlds, and all along, the most otherworldly place we've ever found was right here, beneath the waves, on our own pale blue planet. The deepest place on Earth turns out to be the closest thing to another world that we will ever touch, and we've only just begun to look. And that, when it all comes together, is the wildest part of the whole thing. Not that the deep is so far, but that it's so close. Not that it's so empty, but that it's so full. Not that we've explored it, but that we haven't, not really, not even close. The deepest place on Earth is right here on our own planet, more hostile than space and more unexplored than the surface of Mars. And the few alien things we've glimpsed only show us how little we've actually seen. There's a whole hidden world down there in the dark, and it's still waiting.